One of the tests that I like to run with network engineering and security engineering teams is looking at their network with a sniffer to see if there's any unusual activity that they cannot identify. Now, this test I might run either working in an audit capacity, validating that the network is well managed, that the administration team really knows what's going on, and of course that things are configured properly. I would also do this sort of test as a security test, as a pen tester certainly, though as a pen tester I of course wouldn't invite the security engineering team to be with me, or just doing some technical consulting for businesses. The tool that I'm going to take a look at to do this with you is this tool called Wireshark. Now, Wireshark, you might be familiar with, is a very, very easy to use and wonderful sniffer that's available for most platforms today. If you go to the downloads page, they show stable releases for Windows and OS X, though there are also releases available for Linux and BSD. So you can run this on most operating systems that you find today. Once you've downloaded and installed Wireshark, I have it running over here, when it starts up, it asks you or gives you this nice handy interface to allow you to begin capturing data. And we're actually going to just start it up with the defaults, start capturing data on EN0, which for me is my physical Ethernet adapter, and just let it start collecting data. Now we're going to let that run for a couple of seconds, and while it goes, let's just talk about what it is that we're looking for. We're going to try to identify whether or not there's any activity on this particular network that really doesn't seem like it belongs. Now, the network we're looking at is not a very complex one. There's very little stuff here, but still there are interesting things to find. When you're working in an environment that has hundreds or thousands of computers connected, you'll likely see far more data showing up. Now, one of the questions that is quite often asked when I do this demonstration or do this exercise with a team is whether or not a spanning or mirror port is necessary. And the answer is no. In this case here, I'm just connected to a normal port, no special configuration has been done, and you can see that I'm seeing a fair amount of traffic on this particular subnet. The majority of what we're seeing is broadcast traffic, and that's to be expected. But it's not unusual to see other kinds of communication too. Especially when a switch begins to get loaded, you'll find that every now and then additional packets that are neither for you nor from you will show up on your port, because the switch is simply trying to flush out its buffer so that it can handle and begin to switch again the data appropriately. That's absolutely normal. Before trying to look at something with a span port or mirror port, I recommend you do this first, because otherwise the data could just be too overwhelming to get started. Well, now this has been running for a couple of seconds, let's take a look and see what it is we're actually going to try to do. So let me scroll up to the top here. Oh, actually, I'm going to have to stop it because I have it set currently to follow the data as it shows up, which is going to, of course, make this a little bit more difficult to do. So let me just stop this capture, and we'll just work with the data that we have so far. Now, just in case you've never looked at Wireshark before, let me explain a little bit about what you're looking at. Up here at the top, you're looking at the high-level view of the network, all of the packets that have come by. And of course, you can scroll up and down in this. It color codes it by default to show you different things that are happening, though you can change this color coding or turn it off completely if you'd like to. If you click on one of the packets that shows up here, for instance, let's click on this one right here. This is a multicast DNS packet. If I click on it, notice that the middle window changed. It now shows me all of the different information in that particular packet broken out by the different protocol layers. So I can see the Ethernet here. It's an Ethernet 2 encapsulated packet running IPv6 that has UDP inside of it, and I can see the port numbers, and then I can see and even break open and see what was actually happening. In this case, we had a DNS response, and it's coming back with all kinds of information about something that's going on the network here. Now, that's the middle section, but what about the bottom? Well, let's just click on one of these. For instance, in the DNS response, it says that there were 13 records. If I click on the 13, notice that the bottom window has now highlighted one of the bytes down here, 000D. That's actually a 13 in hexadecimal. Let me just make that window a little bit bigger. And what you're looking at here at the bottom is the entire hexadecimal of this packet, so the raw packet. And you can see the entire thing from beginning to end. So if you wanted to, it's certainly more than we're going to do in this particular episode, but you could dig through and see whether or not this packet was even interpreted correctly by your sniffer. We have no need to do that here, though. Let me close this up, and let's just scoot this window down to give us a little bit more room up here at the top, and see what it is that we're going to do. Now, working with the network engineering or the security engineering team, once the sniffer has been running for a while, we're going to ask them to look at the data that's showing up and tell us if they can explain what that traffic is and why it's on their network. What we're really looking to do is see that all of the traffic that is there belongs there. Now, there is a little danger here. It's not unusual. Maybe you see something like this. Oh, look, there's some spanning tree protocol. And the network engineer says, oh yeah, STP, that's spanning tree protocol, that's used for switch management. That's normal. Normal means several different things. What we're interested in is, does it belong where I see it? Not, is this bad traffic? Is it an attacker? That's not what I'm asking. I want to know if it belongs here. Now we're going to come back to that particular one. Let's take a look at some of the other things that we see showing up here. For example, I can see here that there is some web traffic showing up. Now I'm looking up here in the higher layer. I can see 52480 to HTTP, and if I look down here in the decode, I can see that port 80 showing up. So maybe we talk it over and ask the question, do you allow your internal hosts to talk to external systems on port 80? And the answer, of course, will probably be yes. So every time we identify what traffic is, and we also identify that it belongs on our network, we'll start to exclude it up here. So let's start with this. We'll say if it's not TCP port 80, then it's interesting. So what I've done here is created a filter that will exclude this traffic from being displayed. And as soon as I apply that, you'll see that those packets disappear. Now next, instantly more traffic starts to show up. I can see that there's LDAP traffic. So I have a directory server. It actually does run on 10.0.1.5. And we talk it over, and the network engineer explains what the server is. And yes, that's normal traffic. It's just doing directory lookups. So as soon as that's identified, we add in and not TCP.port equals 389, the LDAP port, and apply it. And very quickly, things start to disappear out of this display. And that's what we're looking for. Now, some other things start to show up here. We can see here, for instance, that we have some NetBIOS name service traffic. The name service traffic here is normal. It might even be expected, but this is where we can start making recommendations. It is really unusual to require that you have NetBIOS name service happening on your network. Now, why do I say that? Well, it's not unusual in that many people are doing it, but it's unusual that you actually need it. In fact, you'd prefer to make it go away because much of it, as you can see down here, is broadcast traffic. And the more broadcasts we have, the more noise and on the network there is, and the slower the network becomes overall. So if I could eliminate those, that would be wonderful. And it turns out that it's very easy to do. Simply installing a WINS service and configuring all of your machines to look at the WINS server through DHCP will eliminate this type of traffic on your network. So perhaps after we talk this over, discuss the fact that they've got constant broadcasts coming out and creating noise, we decide as a group that yes, it's a good idea, we're going to take the action and turn on the WINS service and reconfigure DHCP. Well, once I've made that determination, I'm going to add that in here because I don't want it cluttering up my display for now. So I'm going to say, and not udp.sourceport equals 137 and udp.destinationport equals 137. Now I must have typed something wrong here because it's still red, and I think I left off the T there, but as soon as I put that in, you'll see it turns green. Now, how did I come up with that? UDP and source and destination port? Well, when I highlighted this particular packet, down here we can see, well, actually, let me pick a different one. That's not a good example. I can see that I have UDP port 137 talking to UDP port 137. Now that we know that someone has taken the action item to make that traffic go away, for now, we'll remove it from our display too. And then we begin to see other things. Now I find that I've got other kinds of things happening. For instance, I have some NetBIOS traffic, but it's not from 137. Well, it doesn't have to be. But it does have to be to 137, and in this case we are looking at a NetBIOS name broadcast, seeing if it can look up who the owner of this particular name is. Now we can probably put that under the same umbrella of the traffic that we just eliminated, so let's do this. Let's see if we can generalize this. Well, no, actually, let me leave that one in there, because this is another case. And not UDP.destination port is 137, and now let's see, the destination would be the thing that's changing. So IP.destination DST host, oops, accidentally hit the tab key there, there we go, equals 10.0.1.255, which happens to be the broadcast address on this subnet. So I hit enter, and all of that traffic disappears. Now let's see what else do we have here. Let me scroll up a little bit, and we find some other normal stuff up here. I can see that we have ARP traffic, and if your network is running IP version 4 or really anything other than IP version 6, you are definitely going to need ARP. So we can probably say that ARP can go away. So and not ARP. Those disappear. And you're seeing less and less show up here, and let's see what's left over. For example, I see here that we have CDP, Cisco Discovery Protocol, but notice it's also saying that this could be VTP, DTP, all of the other kind of management protocols. Though in this particular case, it is actually Cisco Discovery Protocol. And it's coming out of, well, a device ID, Cisco 3512XL. It's coming out of a Cisco switch. This is normal in that Cisco switches do this, but this is probably a sign of a misconfiguration. Unless we're actually using something like Cisco Works to track all of the data coming out of these broadcasts, we likely want to remediate that out of our network. It's a sign that we've got a misconfiguration on the switch, and the switch is delivering all kinds of configuration information to the local subnet in clear text. Well, let's make that go away for now. We assign it as an action item. One of the network engineers is going to take care of that. So I'll say and not CDP. That disappears. But that brings us back to the spanning tree protocol. Now this is a big one. This again is normal traffic. However, this is definitely a misconfiguration. The only time I should see spanning tree protocol is when one switch is talking to another switch. If I'm seeing it come out of a port where a computer is connected, that means that those switches are misconfigured. Why? Well, this actually creates a potential for a security vulnerability. If this port is sending out spanning tree, that means that these layer 2 protocol management protocols have not been trimmed off of the port, and it would be possible to convince that switch that I'm a switch too. And if I do that, now it's only a matter of time before I can start taking over the spanning tree, or perhaps joining VLANs I'm not supposed to, or snoop on traffic I'm not supposed to. So yes, it's normal, but it's definitely a sign of misconfiguration. Well, as we work through this with the engineering team, and we assign out action items, getting things taken care of, identifying misconfigurations and things of that sort, we simply make it or document the filter that we come up with. And at the end, what I'll normally do is just make a copy of this and then paste it into a file so that we can keep track of it. Of course, anything that we added in because it was assigned out as an action item, like let's say the CDP and the NetBIOS and other kinds of things, we wouldn't want to keep in that file because we want them to show up in the future. And in the future, either me as an auditor or as a consultant would periodically perform this same test with that group, or even better, we'd like to see that the network or security engineering group sits down and does this kind of an analysis maybe once every 6 months, because networks do change, and they want to be able to have their finger on the pulse of what's happening and identify any unusual activities before it turns into something bad. Well, I hope you enjoyed this particular episode. This is an activity that I really enjoy doing with most of my customers. If you do have any additional questions about it, take a look over in the show notes that are posted over on the SANS site, or feel free to send me an email.